NaxToView is the 3D viewer for the graphical visualization of finite element models of the NaxTo suite. NaxToView has numerous functions. Below, we are going to make a small introduction of all of them, and we will make more emphasis on the ones that we consider that can be more interesting, and that make the difference in front of other 3D finite element viewers. To start with the explanation, the first thing to do is to load a model. The model appears reflected in the 3D window. We can open several windows at the same time, and within each window generate different views. All windows and views are displayed in the session tree section. Windows can be deleted and are deleted from the session tree. The next step is to plot the results. To do this, we have to select the load cases, increments, results, components, and sections we want to plot. You can edit the legend as you wish. You can even save the new legend you have created in XML format to import it when working with other models. The model tree shows the different parts of the model by entities, properties, materials, parts, element types, by connectors, etc. As shown, the different parts of the model can be shown or hidden. Entities, materials, element types, etc. can be hidden. When the different entities, properties, materials, parts of the model are hidden in the model tree, they are also hidden in the 3D window model. The next function you see in the toolbar is a very useful function that allows you to generate derived results. Derived results can be obtained with combinations of different load cases or components using common functions. Results derived from load cases can be of two types, based on a function combining different load cases, or based on an envelope of some load cases, or of all load cases. The next option is component-derived results. With this option, what NaxToView allows is to create derived components. This means that within a result you have a series of default components that appear in the table and that are within the model that you want to combine and obtain a new component that you can call it as you want based on a criterion. That is, combine the different components of a result. The next function is the reports, which are CSV files with all the results in a plain text file for the cases you want, the type of results you want, and the components you want. For example, you can select several load cases, in stresses and with the component you want, and with that information a text file is generated that allows you to make requests and that are dumped in text files with the results of the model or part of the model. The next function that we are going to explain is the animation of results. You can also visualize their deformation. Another very useful function is that of free bodies. This tool is used to make cuts or sections in the structure of a model and obtain the force that goes through that section. To do this, the first thing to do is to create the sections. The first section has already been created. Here is how to create the second section. Next, you have to select the load cases and the increments. Once you have indicated the load cases and increments you want for each section, the next step is to click on the free bodies icon, and you will automatically get the results. The default sections can be edited, and more information can be displayed, for example, total F, total forces or total M, etc. Next, the free bodies of the model are displayed. Next to the option Filter Columns, there is an icon that allows you to export all information displayed in the table to Excel. Columns and rows can be hidden. On the other hand, columns and rows can be selected, and if we do Ctrl+C, it copies the header and the selected columns and rows to be able to copy it, for example, in an Excel, or in a text file. Another function to highlight is the function to create attributes. This function allows you to import results created by yourself. For example, from the stresses you have calculated the fatigue or damage of different elements of the model. That result is external and you have it in different tables in CSV in a certain format and giving a value to each element. So, from the attribute loading you can import the results to display them also on screen. It also allows the creation of derived attributes. In this case the new attributes are created directly from the attributes window. The following buttons are for graphical theme functions, model centering, model visualization, generation of images of what we have in the 3D window, etc. The buttons below are used to remove or add the selected part of the mesh. For example, you select a list of elements from a part of the mesh you are going to work with. The number of selected elements is displayed at the bottom. You can isolate and display only that part of the mesh and display the results exclusively on that part of the model. NaxToView allows scripting at the bottom of the screen. All actions that have been performed during the session are recorded. All these actions are recorded in a log file where all the history of everything that has been done is saved, allowing you to re-execute all these steps or even through Python code by putting loops or conditions. You can customize the tasks you want to do when you load a model. So, if you always follow the same steps when working with a model and there are some tasks that are more repetitive in the process, you could automate them. For the results information there is the output function. What it does is that, if you make a selection in any area of the model, it generates a table with the information that you have on the screen. This information can be exported to an Excel, CSV, XML or PDF file. In addition, filters can be made. The output function is quite powerful, since it can be grouped by types of elements and results to later export them in an Excel sheet and have all the information of the results in table format. Another remarkable feature of NaxToView is that it allows to generate a 3D PDF with the model. The 3D PDF is created with everything that appears in the 3D window. The PDF file created is portable. It is not necessary to have any plugin or software installed on the computer apart from Adobe Reader 11 or higher version to open this file. And to finish this quick review of NaxToView's features is the tag function. The tag tool allows you to add additional information in text mode. Tags can be attached to the graphical window or linked to model elements or nodes, allowing you to represent their information. In addition, it allows you to create operations within the tags. One of the very useful functions of the tags tool is that it allows, for example, to locate the highest values of the model results being plotted. There is a very powerful menu that allows you to create different types of tags. For example, tags in which you select a criterion. You take all the elements that are in the model, and you want the tag to always put it in the top result, and in that tag you decide what you want to appear in the tag, for example, the element ID, the value, the property, and so on. And you can edit the formatting of the tag, color, text, etc. The main advantage of this way of putting tags with respect to other programs is that the tags have a criterion to select on which element is going to be put. For example, the maximum value, so that, if at some point you change the load case, the tag will be updated automatically and will always show you which value point you have selected, in this case the highest. Therefore, you can create standard tags with standard criteria in order to automatically locate the hotspots of the model. It also allows, if you have a very large model with many hotspots and often you have to go zone by zone searching, the tool allows you to locate the n hotspots that the model has and mark them with the value it has. And here ends the brief review of what are the functions of NaxToView and how you can work with NaxToView. We hope you enjoy it.